Welcome to this in-depth presentation on AWT, the abstract window toolkit within the context of object-oriented programming concepts. Developed for Java, AWT empowers developers to craft intuitive graphical user interfaces through components like buttons, labels, and text fields. By leveraging AWT, applications become user-friendly and responsive, seamlessly enhancing the end-user experience. Moreover, event handling in AWT allows programs to interactively respond to user actions such as mouse clicks and key presses, enabling real-time feedback and engagement throughout the application. Its cross-platform capability ensures visual and functional consistency regardless of the underlying operating system, facilitating wider adoption and deployment. Let's move on to the fundamental object-oriented principles in AWT. AWT's foundations are deeply rooted in the four core principles of object-oriented programming, which are encapsulation, inheritance, polymorphism, and abstraction. Encapsulation. In AWT, encapsulation is achieved by utilizing private fields for internal states and public methods for interaction. This separation protects data integrity and encourages modular design. Inheritance. Developers can easily extend AWT classes to build custom UI components. This fosters code reuse and simplifies the creation of new elements suited to project requirements. Polymorphism. Polymorphism is embodied when overriding methods such as paint, enabling customized graphical rendering for specific components and scenarios. Abstraction. Through abstract classes, AWT delivers a flexible approach to designing interactive components and allowing for extensibility and adaptability across evolving project needs. Components of AWT. AWT provides a comprehensive suite of elements and functionalities for building graphical applications. User interface components. These include button, label, and text fields, forming the backbone of Java visual interfaces. Event handling support. The Java event model enables dynamic response to user inputs such as clicks or key presses, fostering interactive application development. Graphics and imaging. Specialized classes allow for sophisticated drawing, image management, and custom graphical displays on components. Layout managers. AWT's variety of layout managers helps structure and organize UI components efficiently, ensuring aesthetically pleasing and functional design. Event handling mechanism. Effective event handling is crucial for GUI interactivity. AWT uses an event-driven approach, processing flows that react to user-generated events. Typically, the event cycle begins with detection, checks for valid events, and proceeds with appropriate handlers. This model can be visualized through a flowchart that outlines decision points and response loops. Let's examine the difference between AWT and Swing for Java GUI development. Feature. Weight. Heavyweight components depend on native OS rendering in AWT, lightweight fully handled by Java in Swing. Platform consistency. Platform dependent appearance behavior in AWT, platform independent consistent look in Swing. Components. Limited set of GUI elements in AWT, rich diverse set of components in Swing. Event handling. Event listeners can be cumbersome in large projects in AWT, more sophisticated, user-friendly mechanism in Swing. Flexibility. Less control over aesthetic and behavior in AWT, greater customization and modern UI capabilities. Let's see about components hierarchy and structure. AWT organizes its graphical elements in a well-defined hierarchy, which are top-level containers, basic components. Top-level containers serves as the root for all components, managing lifecycle and layout. Containers hold and arrange multiple components, controlling their structure. Basic components, the foundational units for all visual interface elements. Practical applications of AWT in projects. AWT has proven its utility in diverse project scenarios. For instance, desktop applications often faced challenges in UI design prior to AWT introduction. By employing the toolkit, developers achieved greater efficiency in GUI construction, streamlining workflow, and speeding up development cycles. This transition not only solved usability problems but improved project outcomes by enhancing the overall user experience. Let's see about challenges and best practices in AWT. Despite its strengths, AWT presents certain limitations. Event handling can become complex, especially in larger applications. AWT components are less flexible than those offered by newer libraries. Developers may face limited control over aesthetics and applications behavior. Cross-platform compatibility must be verified as some inconsistencies may arise. Best practices include understanding AWT's limitations, focusing on design flexibility, paying close attention to UI aesthetics, and thoroughly testing across multiple platforms to ensure reliability and usability. Case study: AWT implementation. Consider a real-world scenario. Difficulty in crafting a responsive user interface was addressed by integrating AI components. The outcomes was enhanced user experience due to improved responsiveness. The journey involved analyzing interfaces issues, redesigning layouts with AWT, implementing challenges in code, and conducting rigorous testing. Future trends and developments. AWT continues to evolve, maintaining its role in Java desktop applications. Key trends include enhanced interactivity through new lightweight components, seamless cross-platform execution, making Java application versatile and robust, advanced event handling frameworks for greater control and efficiency, and ongoing integration of modular design philosophies for improved user experience. Let's see about key takeaways. To summarize, AWT is a foundational toolkit for Java graphical user interfaces. Its component hierarchy promotes modular and flexible design. Event handling is a strength but can be complex in larger systems. Platform independence and object-oriented integration support code reuse and portability. Developers are encouraged to test for compatibility and prioritize user experience in UI design. Thank you.